1.5 times 12.
All right. Today is still the beginning of the semester, so I share the.
Now, what is 1.5 times 12? So it's basically 12 plus half of 12, which is 6. 12 plus 6 is 18.
But tools is really useful. Okay, and okay, let me switch to the next one.
18 minus 18 is 0. 30 plus 18 is 48.
Next week,
So,
please do me a favor.
do we have any outliers?
Please bring
Are there any numbers outside of this range?
USB disk.
And it turns out that there is. The maximum 50 is not between 0 and 48. So this
Portable app.
is an
You
outlier.
can do it now. You can do it now. Just type portable apps.
Now going back to our original data,
Portable
I'm
here,
just going to rewrite it
not a pro.
so
Sorry.
you could see everything. This is what we had.
Here, you will get these portable apps. In short words,
So now at this point,
software
let's go ahead and
can be
let's make a number
placed
line.
in a USB disk. And as long as you come to
So 0 is
the
going to be our
library,
lowest point.
computer,
We're going to go up
the
to 50.
department office
So
of
let's go
the
by
computer,
tens.
All this computer classroom bring the disk and all information and
Now let's
should
put a mark
all
in the middle
software is
to represent
on
the
disk.
5s.
And when you finish the work,
So let's
don't
begin by drawing a
forget
box.
bring the
So we need to draw a box ranging from
unplug the
Q1 to
USB disk
Q3.
and bring it home.
So that's going to start at
And
18,
next time,
and this is basically a
please
rough
do that.
estimate.
Or you can
It's not going to be
search,
perfect.
You can read a
And the
lot
end of the
information
box
about this.
will be
But
at
next
30.
week I will tell you how to do this. Is that okay? You can.
Now,
portable
13
apps,
is
let
the
me
minimum,
test them.
which is approximately around that area. So that's the left side of the box. And 50 is the maximum, but that's an outlier. So we're going to just put a point at 50. 38 is the second highest, which is not an outlier. So that's going to be part of the box and whisker plot. And so 38 is in this region. So we're going to say it's over there. Now, Q1 is 18, Q3 is 30, but we also need to write where not Q4, but where Q2 is. Q2 is 24, which is around here. So this is Q1, that's 18, Q2, and Q3.
The gentleman share the delicious
So the left of the
healthy
box
food,
represents the
and about the
interquartile
photo.
range,
Now I'm going to show
which
you how
is
to
12.
find
That's
copyright
30
free
minus 18.
or free license
So here is the
photos,
minimum,
then you can
and this
use
is
on your website.
the maximum,
Please go
which
to
is the
Flickr.
outlier. But that's how you can construct a box and whisker plot
.com,
given a data set.
Flickr.com.
Now the next topic we need to talk about is skewness. So let's say we have this representation
Go to the
of our data.
Flickr.com
And notice that it is symmetrical.
and excuse me, what kind of healthy food
This line
you,
represents
the spelling of the
the
healthy
median.
food?
And if you have a data that is
Can you tell
perfectly
me the
symmetrical,
spelling of the healthy food?
the mean, this is the sample mean, it's going to be equal to the median.
Healthy.
Now, the box and whisker plot will look something like this. Q2 is going to be right in the middle of Q1 and Q3. So notice that the box plot is evenly distributed. The left side is the same as the right side in length. And also, these lines are equal in length. So that represents a symmetric distribution. Now, what if it's not symmetrically distributed? What's going to happen in that case? There are two possibilities. The data can be skewed to the right, or it can be skewed to the left.
And, okay, the key step is here.
So which one would you say
License, please
this particular
select
shape represents?
Commercial use allowed.
Would you say it's skewed to the right or skewed to the
Key
left?
point is here.
Notice that we
In the
have
future,
a tail that extends towards the right.
In the future, your website
So this particular data,
become a big website,
or this graph, we can say that it's skewed
use a lot of copyrighted materials.
to the right.
It will be a nightmare.
Now, what is the relationship between
So in the beginning,
the
when
sample
you
mean and the
establish
median
your website,
in this
you can
case?
use the commercial
So the median, the
allowed
middle portion of the data,
or
will be somewhere in this region,
copyrighted
and the sample mean
materials. Again,
will be
here
to
is
the
key
right
step.
of the median,
You can go to many
since
websites,
it's
but
skewed to
I
the right.
prefer to use Flickr.com.
So the mean will be greater than the median
Search
in this
the
case.
food or the anything you
By the way,
like.
whenever you have a shape
Then
that's skewed to the right,
analysis, select commercial use
some
allowed.
textbooks will refer this
It's a key
as a
step.
positive skew. And it makes sense because positive numbers on a number line
Sorry, no.
will be on the right side.
Oh, okay. Maybe I can.
Now, you need to be familiar with the box and whisker plots for this type of distribution.
Okay, can you tell me? Yeah.
So here's one example.
No,
Notice that the right side of the box is longer than the left side. So this tells us that Q3 minus Q2 is greater than Q2 minus Q1. And so in that case, looking at the box and whisker plot, you can see that it's skewed to the right. Now sometimes these two boxes may be equal in length.
And for example, if I plan to find cake,
Nevertheless, this side might be longer than this side.
I am looking for
So
the commercial
even if the boxes
use
are
allowed,
of the same length,
and
if this side is longer,
type enter.
it will also be skewed to the right.
And if you like this one,
Now what about if it's
and,
skewed
just
to
to
the
remember,
left? In this case, the graph is going to look
search
something
for
like
the
this.
appropriate license.
Let me try that
Here
again.
is allow everybody to commercial use.
So notice that
That's one
the
thing.
tail
And
is on
and
the left side.
remember
So in this case,
to
we have a
cite
negative
it.
skew, or we could say
If
that
you
is skewed.
If you
to the
don't
left.
cite it or use have a appropriate source of this, that is a pirate.
Now the median will be somewhere in this
So
region,
let me demonstrate how to do this. If
and the
I
mean
like this,
is going to be to the left
take the photo
of the
here.
median, since it's skewed to the left. So the
This
sample
part is
mean is
important.
less than the median.
If you forget it, remind
Now
me.
how can
I
we
can
represent
say it
this
many,
using
many
a
times.
box plot?
If I like this cake,
Well, here's one possibility.
download it. And
So in this
different
case,
resolution,
Q2 will be
you can select the
closer
SD1.
to Q3
If I select the
in the
middle
box
one,
plot.
the medium,
So as you can see, the left side is
okay,
longer
and
than the right side.
here is the key step here. Copy
So we can say that
and go to the
Q2 minus Q1
text.
is greater than Q3
Here is the
minus
website.
Q2 in this case.
And I use
Now,
the
if the
photo.
boxes are equal in length, you can also tell that we have a negative skew
Download.
if the left side of the box plot is longer than the right side. So that's another indication that
Okay.
the data is skewed to the left.
Source.
Now, there's some other things that you need to know if you're going to take a statistics course. And you need to be able to
The
create
order is here.
a dot plot.
The
So let's say if you have the
license
numbers
is
5,
here.
8, 3, 7,
Some rights
1,
reserved.
5,
Again,
3,
not all
2,
rights reserved. Just
3,
some rights.
3,
Which
8,
rights
5.
are
With this
reserved
information, how can we construct
by and
a
shared
dot
by?
plot?
It means as long
Well, we
as
could begin
follow
by
those two rules,
drawing a
as
number
long
line.
as we
So let's say this is 0,
use
1,
we cite the
2,
author
3,
and use it as
4,
the same
and
way.
so forth.
We can use it for any purpose.
We could stop at
And
8 since
if
8 is the
we
highest number.
Use this photo and modify it,
Now the first
in the
number is a
future, we
5.
should
So
follow
all we
the
need to
rule.
do
We should
is
follow
draw
the
a dot
same license
above the
to
number
use
5.
it, but no
And then let's
restriction on
put the dots one at a
commercial
time.
purpose.
So the next number is an 8. So we're going to draw a dot at 8.
I have no idea about
And then
international
it's a
students,
3.
but in
So
Taiwan,
let's put the dot there.
it was horrible.
Next we have 7.
Because higher education and the Ministry
And then it's 1.
The Ministry of Education, they
And then a 5. So notice that we have a second 5. All we need to do is draw another dot above the first one. And then it's a 3, 2,
I take all responsibility.
and then another 3,
You can check my YouTube
and another
channel.
1,
I'm live streaming
and then
now.
8,
Again,
and then
this
5.
knowledge is very easy. But in Taiwan,
So that's how you can make
I
a
cannot
dot
allow
plot.
international students. Okay. In Taiwan,
Now using this dot plot,
only few people
which
know
number
this,
is
and I
the
teach you
mode?
this. Okay.
What would you say?
If you plan to use this
Now if you recall, the
photo
mode
for commercial
is the
or
number in the
commercial
dataset that
purpose,
occurs
that's
most
okay.
frequently.
But
So in this
now,
case,
the
it's the
author
number with the most
asks
dots.
all readers follow
So the
rule
mode for
here.
this dataset is 3.
By
the
this,
way, if
I
you
need
haven't
to
done so
cite
already,
his or her
don't
name.
forget to subscribe to
Share
this
like,
channel
share like.
and click on that notification bell. Now let's talk about how we can make a stem and leaf plot.
And
So let's say we have the
CC
numbers 4,
by
9,
and
13, 13, 17,
Again.
21,
Again, if you use the
36,
photo with copyright materials, in
38,
the future, when you become a
say
famous one, you want to
another
establish
38,
a company, you want to
and then
continue to
56.
use the website you established
How
when
can we
you
make a
was
stem and leaf plot
student.
with this data?
Sorry, you need to remove the
So the first thing we need to do
copyrighted photos.
is we need
Thus,
to
in
write
the
2
beginning, you
columns.
select only
On the left,
commercial
it's going to be the
allowed
stem,
photos.
and on the right,
It
the
saves
leaf.
your time.
So the first number is
I believe
4.
maybe I'm the only teacher
So for the stem, we're going to
in
write 0.
campus
And for the leaf,
who
we're going to put
teach you
4.
This concept.
The next one is 9.
It's 9
So we're
May.
going to write
It's
or
9 May.
represent
But
9 as
you
0,
don't
9.
need to believe
So we
all
have 0
words
on the
I
left,
speak, but you can
and then we're going
check
to put
the
9
other
on the right.
Creative Commons.
The next
in
number
English. I think you can read it.
is
You can read it.
13.
Okay. Any question?
So the
If no
first
question,
digit is
we
a
will go
1.
back to our
The second
textbook.
digit we're going to put in the second column.
Okay.
Now we have another 13. So all we got to do is add
2
another
minutes,
3.
and we will switch back to our
Now for
text.
17, we need 1 and 7. We already have the 1, but we need to write the 7 to the right side. Now for 21, we need to put a 2 in the stem column, a 1 in the leaf column. Next we have 36, so we need a 3 in the stem column, a 6 in the leaf column. Now notice that we have 3 38s, so we got to add 3 8s to the leaf column. And finally, 56. Now we don't have anything in the 40s, so we're going to write a 4, but we're not going to put anything here. For 56, we're going to write a 5 in the stem column and a 6 in the leaf column. And so that's how you can make a stem and leaf plot. Now it's always good to have a key. So we could say that 2, 1 represents 21. So if someone looks at the stem or leaf plot, they know what you mean. Let's try another example. So let's say we have the numbers 56. Actually, let's say 78, 85, 89, 92, 106, 107, and 119. Go ahead and make a stem and leaf plot with those numbers. So the first number, 78, we're going to write a 7 in the first column and an 8 in the second column. Next we have 85 and 89. So we're going to put an 8 for the first digit and then 5 and 9 for the second. And then it's 92, so we're going to write 9 and 2. Now for 106, we're going to put a 10 in the stem column, but a 6 in the leaf column. And for 107, we just got to add a 7 here. And there's usually no commas, so let's get rid of that. And then finally, for 119, we're going to write 11 in the stem plot and 9 in the leaf column. And so, for example, this will be our key. So this represents 92, and this would represent 106. Because sometimes you could have decimal values. For instance, let's say if we have 1.2 1.6, 1.8, 2.1, 2.3, 2.3, and 2.5. We can construct this stem and leaf plot like this. So we could start with 1, and to write 1.2, we could just put a 2 for the leaf plot. Now for 1.6, we just got to put a 6 in the leaf column. And for 1.8, just an 8. Now we can move on to the 2's. So we have 2.1, 2.3, 2.3, and 2.5. And so that's how you can make a stem and leaf plot using decimal values. So we could say 1.6 represents 1.6 in this particular example. Now the next thing we're going to talk about is something called a frequency table. So given a data set, how can we make a frequency table? So let's say we have the numbers 5, 9, 8, 7, 8, 12, 9, 8, 10, 8, 9, 7. So using those numbers, how can we make a frequency table? We're going to put 2 columns. So the first column will represent the number, and the second column will represent the frequency. And let's put down what we have. So the first number is a 5. And how many 5s do we have? There's only one 5, so the frequency is 1. The next number is a 7. And notice that we have 2 7s, so the frequency is 2. Next is 8. We have a total of 4 8s, so that gives us a frequency of 4. After that we have 9, and I've spotted 3 9s, and then there's 1 10, and we have 1 12. So that's a simple way in which you can make a frequency table. Now, here's another question for you. How can we use the frequency table in order to calculate the sample mean? How can we calculate the average instead of just adding all of those numbers up and dividing by the number of data points in a set? Let's add another column. And we're going to call this the sum. Now, we have 1 5, so 5 times 1 is 5. We have 2 7s. If you add up 7 and 7, you get 14. We have 4 8s. 8 times 4 is 32. Or if you add 8 4 times, you get 32. 9 times 3 is 27. 10 times 1 is 10. 12 times 1 is 12. Now we're going to add up the sum column to get the total sum. So 5 plus 14 plus 32 plus 27 plus 10 plus 12, that's 100. And we're also going to add up the frequency column. That's going to give us the total number of numbers that we have here. So we have 1 plus 2, which is 3, plus 4, that's 7, plus 3, that's 10, plus 2, that's 12. So we have a total of 12 numbers. So the mean is going to be the sum divided by the total number of points that we have in our set. So it's 100 divided by 12. So the mean in this example is 8.3 repeated. And so that's how you could use the frequency table to calculate the mean of a data set. Now the next thing that you need to know how to do is how to create a histogram. A histogram looks like a bar graph. But unlike a bar graph, a histogram has its bars connected to each other. So here's an example of a histogram on the left side.
There are many other examples for this area. To understand
On the right side, I'm going to draw a bar graph.
You need to understand
So this would be a bar graph. So as you can see, they're very similar, but the bars in a histogram, they're adjacent to each other. There's no space in between. But how do we go about taking a data set and making a histogram? So let's say we have the test scores of students in a typical class. Let's say the test scores are 65, 72, 93, 68, 76, 98, let's say 84, 85, 79, 88, 90, 82, 83, 87, and 78. Now the first thing we need to do is create a frequency distribution table. And so what we're going to do this time, rather than talk about how frequent, or rather than describing the frequency of each number, we're going to break it up into categories or classes. On the left side, we're going to have the grade. On the right side, the frequency. Now, I'm going to categorize the grades in levels of 10. So a D would be 60 to 69. A C would be 70 to 79. A grade of a B would be 80 to 89. And an A is going to be 90 to 100. So those are our four categories or four classes. Now, how many students received a grade between 60 and 69? So notice that there are two students. We have the grades 65 and 68. So the frequency will be 2. Now, how many students received a C on their exam? How many students received a grade of somewhere between 70 and 79? So we have 1, 2, 3, and 4. So 4 students got a C on their exam. What about a B? So we have 84, 85, 88, 82, 83, 87. So I counted a total of 6. And what's left over are those who got an A, a 93, a 98, and a 90. So now that we have our frequency distribution table, we can now make a histogram. So on the y-axis, we're going to plot the frequency. On the x-axis, we're going to put the grades. So the grades will vary between 60, 70, 80, 90, and 100, because the classes are separated by intervals of 10, approximately. Now, the highest frequency is 6, so let's go by 1. 1, 2, 3, 4, 5, 6. So let's plot the first one. Between 60 and 69, which is close to 70, the frequency is a 2. So it's going to look like that. And then between 70 and 79, 4 students got a grade in that region. I'm going to use the same color. And between 80 and 89, 6 students fall in that category. And between 90 and 100, only 3 students received an A. So let's put the grade. So this is a D. 2 students got a D. 4 students got a C. And 6 students received a B. And 3 students received an A. So that's how you can create a histogram from a data set like this using a frequency distribution table. Now, there's something else that we need to go over, and that is making a table with the frequency, the relative frequency, and also the cumulative relative frequency. So let's say we have the numbers 2, 3, 5, 3, 6, 8, 7, 8, 3, 3, 5, 3, 7, 3, 8, 5, 2, 7, 8, 3. So we're going to have 4 columns. The first column is going to be the value. The second column will be the frequency. The third column is going to be the relative frequency. And the last one is going to be the cumulative relative frequency. So the lowest value that we have in our list is 2. And notice that we have 2 2's. So the frequency for that number is 2. Next, we have a 3. And we have 1, 2, 3, 4, 5, 6, 7 3's. So that's the frequency. The next number in the list is 5. We have 1, 2, 3 5's. Now we only have 1 6, which is here. Next is a 7, and there's 1, 2, 3 7's. I need to extend this list. And then finally we have some 8's. 1, 2, 3, 4 8's. Now let's take the sum of the frequency column. So if we add these numbers, 2 plus 7 is 9, plus 3 that's 12, plus 1 is 13, plus 3 is 16, plus 4 is 20. So we have a total of 20 numbers in our set. Now how do we calculate the relative frequency? So for the first entry in that column, take the frequency and divide it by the total number of numbers that you have in the data set. So the relative frequency is basically the frequency divided by n. So for the first one, it's going to be 2 over 20, which is 1 out of 10, and so that's 0.10. For this one, it's going to be 7 divided by 20, which is 0.35. And for the next one, it's 3 divided by 20, which is 0.15. And then it's 1 divided by 20, that's 0.05. 3 over 20 is 0.15 again, and then 4 out of 20 is 0.20. Now, if you add up all of these numbers, you should get 1. Next, we have the cumulative relative frequency. So we're going to start with 0.10, and then we're going to add these two numbers. 0.10 plus 0.35 is 0.45. Now, 0.45 plus 0.15, that's 0.60. And then if we add 0.60 and 0.05, that's going to be 0.65. And then add in those two numbers, that's going to give us 0.80. And then 0.80 plus 0.20 will give us 1. So that's how you can complete the cumulative relative frequency table given a data set. Now, let's talk about how we could use this information. Using this table, what is the value of the 60th percentile? What would you say? So what we need to do is look at the cumulative relative frequency. So the 60th percentile will end here. Now notice that it's exactly 0.60, which corresponds to 60%. To find the 60th percentile, you need to average these two values. So you have to do 5 plus 6 divided by 2. The average of 5 and 6 is 5.5. And so that's going to be the 60th percentile. Now what about the 80th percentile? So notice that we have exactly 0.8 in the cumulative relative frequency column. So what we're going to do is we're going to average these two numbers. The average of 7 and 8 is 7.5. Now what if it's not listed in the cumulative relative frequency table? For instance, let's say if we have, or if we want to find the 20th percentile. What value corresponds to that? Now the 20th percentile is between 0.10 and 0.45. It's important to understand that after 0.10, you're going to exceed the value of 2. You're going to go into the 3s. And after 0.45, you're going to move from the 3s to the 5s. So the 20th percentile, because it's more than 2, but less than 3, it's going to be 3. There's no numbers in between here if you look at the data that we have. So the 20th percentile is going to fall in this number. To explain it better, it's important to understand that between 0 and 0.10, the value is 2. Between 0.10 and 0.45, the value is 3. Now, if your percentile falls between 0.45 and 0.60, not including 0.45 and 0.60, but if it's between those numbers, then it's going to be 5. It's going to be 6 if it's between 0.60 and 0.65. And it's going to be 7 if it's between 0.65 and 0.8. So let's say if we want to determine the 75th percentile. The 75th percentile is between 0.65 and 0.8. So because it's more than 0.65, we're not going to have the value 6. We're going to get 7. So that's going to be the 75th percentile. Now, let me help you to see this visually so that it makes more sense. Let's begin by arranging the numbers in increasing order. So we have 2 2s. We have a total of 7 3s. And we have 3 5s, 1 6, 3 7s, and 4 8s. Now, I'm writing these in pairs of 2s, and you'll see why. We have a total of 20 numbers, and if you take 20 and divide it by 2, you're going to get 10 equal parts. So this is going to be the 10th percentile. Let me put that in a different color. So here's the 10th percentile, the 20th percentile, the 30th, and so forth. So this would be the 100th percentile. There's nothing higher than that. So the first thing that we went over was the 60th percentile, which is here. So notice that we have a 5 on the left and a 6 on the right. So we need to average 5 and 6. And so we said the 60th percentile was 5.5. The second one was the 80th percentile, which is here. Notice that it's between 2 different numbers, 7 and 8. So if we average 7 and 8, it will give us 7.5. Now after that, we talked about the 20th percentile. And the 2 numbers that it's between are identical to each other. So therefore, the 20th percentile is just 3. And the last one was the 75th percentile, which is between 70 and 80. And so these 2 numbers are just 7. And so the 75th percentile has to be 7. So now you can visually see the values that correspond to the different percentiles. And if you want to, you could put 0 as well. I forgot to do that. But that's basically it for this video. So hopefully it gave you a good introduction into statistics. There's a lot of other stuff that you'll learn in this course, but these are just some of the basics. Thanks again for watching. So what is statistics? Statistics is basically the science of collecting, analyzing, and interpreting data, even presented it as well. And statistics can be broken down into 2 categories. On the left, we have descriptive statistics, and on the right, inferential statistics. So let's focus on descriptive statistics first, because you're going to learn that first before you learn inferential statistics. In descriptive statistics, you're basically organizing and summarizing data using numbers and graphs. For instance, you could summarize your data using a bar graph, which looks like this. Many of you have seen this in middle school or high school. You could even organize your data into a histogram. A histogram looks like a bar graph, but the bars are basically attached to each other. So that's the difference between a histogram and a bar graph. You can also organize your data.
Okay, then for example, you can copy the definition here. Definition: statistics is the study of how to collect, organize, analyze, and interpret the data collected from a group. You can copy and paste it. Then you can have your notes. For example, to collect the information of man's height in Taoyuan. And you just cite the original sentence from the textbook, and you can write down your notes. And it's an open textbook. It's legal to use it on your website, but you need to clearly express that the author is Catherine Kozak. The copyright issue is about Creative Commons by ShareAlike 4.0. Then I have a question. Can you use this textbook for commercial purpose? The answer is yes, because no restriction on commercial. As long as the guy's knowledge is valuable. I have no idea, but when I was in the US, nobody discussed about this. But you can check it. Okay, let me switch to a different issue here. Creative you can check the Creative Commons. There's the most famous open licenses, and you can check the Creative Commons here. Oh, not this one. Okay, I'll get it for you. Okay. Then you can write down the notes here. That is your part. Maybe you can switch it to the blue texts. Get it? And in the future, I hope you can use your cell phone as the mini laptop. And when you join different, for example, the business or the accounting, you can write down notes like this. And you can copy and paste the different definition here. Definition 1.1.1. And the second definition is here. Copy. Oh, come on. Copy and paste it here. Okay. individual, person, or object that you are interested in finding out information about. And on the other has an example: water bottles, or people's information. And this part is your note, okay? Actually, I ever attended a lot of license training courses when a teacher in the KNU. Every time I brought my laptop to the course and I tried to write down notes by typing. And for example, about how to escape in a fire when the building is on fire. And the lecturer gave us a special term. I don't know that. Then I can search the term immediately. Okay, the restriction in the fireplace is something like this, and I write down the notes. So I try to give you different concept about this. Okay, one more minute, then we can switch to next paragraph. And I just explained here the definition of sample. And you can have your notes like this. It is not, or it is impossible to get the whole information from the population. Thus, let's try to select a small amount of individual that is feasible. Okay. And here is your note. Okay, get it? Okay, you can copy and paste the reasonable information with open license text. That's okay, but you need to write out your own notes, your thought here. That's your own knowledge. That's your own notes. I made some mistake in English grammar spelling. That's not a big issue because I can correct it later. But the moment you can write down all notes on your website. Is it okay? Okay, we have a few minutes to go. I think I should stop here. And if you have any question, stay here and we can discuss. Is it okay? And next time, the gentleman joined our online group. Now, yeah, I will give you the QR code you can scan to enter our note. And I try to give you the reading materials about the different chapters and some during class assignment. For example, next week I will ask you. So I will suggest you to bring a thumb disk. Then we will make the portable app, and all information, all software on the thumb disk, USB disk. Then you can do it. USB USB. But you have your laptop. You don't need to do that. Because the students, maybe they forgot to bring their own device, they can use the computer here. And I encourage them to prepare a USB disk. Okay, let's take a rest, everybody. And if you have any question, come to here, we can discuss. Okay, see you next time.